Hello, this is Mrs. Huntley. This is Module 4, Lesson 12B. You should be on page 103 of your student workbook. And if you remember, in Lesson 12A, we had not finished the entire lesson, so this is kind of a long one, but it's an important one. So I wanted to make sure that you had the teaching available for 12B. Now, if you were in class today, it is possible that we actually worked through some of these problems and you're like, well, why are we doing the same thing again? This is for people that perhaps weren't in class today or didn't fully understand it. So this first problem in particular, if you were at school today, we probably worked through it together, but you're going to want to, you can either, again, watch it, or you can fast forward to the next problem or pick up the one that you didn't get in class today. So page 103 starts with find 5 solutions for the linear equation x plus 5y equals 21 and plot the solutions on the coordinate plane as points on the coordinate plane. And the table on the left says begin by fixing x and solving for y, and the table on the right says in this table fix y and solve for x. So you're like, fix, what does that mean? Fixing a value means you will choose a value for one variable and solve for the other variable. So over here on the left, we're going to be choosing our x's and solving for our y's, and here we're going to choose our y's and solve for our x. It's exactly the same equation. So one is not going to be, solving the equation is not easier or harder because it's the same equation, but your approach to how you solve the equation. One is going to be easier, one is going to be harder. Not impossible, not something you can't do, but a little bit harder to think about. So let's start like we always start, and let's pick a value. On the left here, we're fixing x, so we're going to pick a value for x. I always like to start with 0. To me, 0 is easy math, easy to think about, gives you a starting point. So I've got 0 plus 5y equals 21. I could subtract 0 from both sides, but that's just going to be, 5y equals 21. I want my y by itself, so I'm going to divide both sides by 5. So y is going to be equal to 4 1/5. Or if you're using your calculator, you might have gotten 4.2. Either way would be correct. So I'm going to say 4 1/5 or 4.2, either way. So now I'm going to do the same thing. I'm going to actually jump between the two tables and then we'll just compare. That wasn't terrible, except we got that fraction at the end or the decimal at the end. So it wasn't that hard. I can do that. Let's check this side. I'm going to solve for y here. X plus 5 times 0 equals 21. Now 5 times 0 is 0, so x plus 0 equals 21. I could subtract 0 from both sides, but I'm just going to get x equals 21. Huh, that was pretty straightforward, and I've got whole numbers on both sides, so it wasn't that much easier, I guess. So why don't I go on? We'll continue, and we'll make a conjecture about which one's easier in a little bit. So I'm going to start here. I'm going to go x is equal to 1. So 1 plus 5y equals 21. Got to subtract 1 from both sides. 5y equals 20. Now divide both sides by 5, and y is going to equal 4. Oh, that was nice. I get whole numbers on both sides, so that was really nice and easy. Let's try this one. If I set y equal to 1, so I'll have x plus 5 times 1 equals 21. 5 times 1 is just 5. Subtract 5 from both sides, and x is going to equal 16. It seemed like fewer steps there. I don't know, that one seemed pretty good to me. Let's continue on with our same pattern. So I'm going to say x is equal to 2. So 2 plus 5y equals 21. Subtract 2 from both sides, and 5y equals 19. 19 divided by 5. I don't know that off the top of my head. It's going to be 3 4/5. or if you're using your calculator, you might have gotten 3.8. So 3 4/5 or 3.8. Okay. That got a little bit tricky because I don't, off the top of my head, necessarily know what 15 or what 19 divided by 5 would be. I know that 5 times 3 is 15, and that's 4 away from 19, so it's going to be 3 4/5. But that takes some extra brain power to get there. Let's see what happens on the other side. If I plug in a 2 for y, x plus 5 times 2 equals 21. 5 times 2 is 10, so x plus 10 equals 21. Subtract 10, and x equals 11. That was easy peasy. I didn't have to worry about a decimal or a fraction or anything like that. That was nice and straightforward. I liked that a lot. Let's do one more before we make our conjecture. So if this is a 3, 3 plus 5y equals 21. So I'm going to subtract 3 from both sides. And 5y is going to equal 18. Divide both sides by 5. And again, I know 3 times 5 is 15. So 15 is 3 away from 18, so that'll be 3 3/5. Now I do see a pattern here. So I can continue with that pattern. But it's really going to be hard to graph this too. My points on my graph are going to be super close together. And on my graph, I have whole numbers, not fifths. So that's going to make it a little bit more challenging as well. Let's check what happens when I plug in 3 over here. So x plus 5 times 3 equals 21. 15 equals 21. Subtract 15 from both sides. 21 minus 15 is 6. So again, I have whole numbers. That's going to be easy peasy to graph, and I won't have to deal with my numbers being all bunched up in one tiny little part of the graph. So which table is easier to complete? I think the table on the right, fixing my y, was easier to complete. I got whole numbers. Oops. I got whole number answers in fewer steps. Why do you think it's true that fixing y was easier than fixing the x? What's happening to the y? Well, y is being multiplied by a 5, isn't it? Y has a coefficient. So I get, and x is all by itself. So once I do that multiplication of the y term and I subtract it from both sides of the equal sign, I'm just left with my x. There's nothing to divide by. I don't have any messy numbers or messy fractions. So a really good rule of thumb would be if you have an equation in standard form and one of your variables has a coefficient, that's the easier one to select values for and fix and solve for the other one. Let's go ahead and graph our data and see if we find any patterns here. Now it's going to be hard to graph some of it because we weren't given a coordinate plane that's large enough to do 0, 21 or 116. So I'm going to go ahead and do my whole numbers only at this point. So I'm going to do 1, 4, and then 2, or 11, 2, and 6, 3. So 1, 4. I come to 1 here and then go up 4. 1, 2, 3, 4. And then I've got 3, 1, 2, 3, and then up 6. I'm sorry, 6. 1, 2, 3, 4, 5, 6, and then up 3. 1, 2, 3. And then I've got 11, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. I'm going to get rid of all these little extra dots in here so they don't confuse you, because these blue dots are the whole numbers from my graph. Now, if I try to put in these little tiny fractions like 0, 4.15, I'm going to be at, don't go right or left, and I'd be right up here, which is fine. I mean, it would fit on the graph, but all of my data would be like really jammed in right in that area. So I don't know. I think we made a good choice. Let's take a look for some patterns here. I want to see if there's any patterns on our graph. So if I'm trying to get from, say, this point to this point, and thinking about, you know, I can't draw a straight line. I need to go just on the main streets. You pretend like these are cars and this is a grid pattern in a city. I'm going to have to go down 1 block and then right 1, 2, 3, 4, 5 blocks. So down 1 and right 5. It's the same thing between each of the points. So I'm going to say that there's a pattern here that if I went down 1 and right 5, if my graph actually went out there, that this point would be on there. Let's see, that would be 11, 12, 13, 14, 15, 16, 1. So that one would be on there. So I'm going to see if perhaps I went to the left 5, 1, 2, 3, 4, 5, and then up 1. If that point would also be a solution. So that's going to be negative 1, 2, 3, 4, negative 4, and then 1, 2, 3, 4, 5, positive 5. Let's see if that works in our equation. So our equation was x plus 5y equals 21. So x is negative 4 plus 5 times 5. Does that equal 21? See, there's my x, there's my y. Negative 4 plus 5 times 5 is 25. Does that equal 21? See, negative 4 plus 25, yeah, that's going to be 21 equals 21. That is a good solution. So that one would work. I can pick out solutions off of my graph if I recognize that there is a pattern in the graph. Similarly, there's going to be a pattern in our table. My y is going up by 1 each time. So I'm going to say, without doing any math, that 4 is going to be my next choice there. This is what's happening here. 21 to 16, that's going down by 5. 16 to 11, down by 5. 11 to 6, down by 5. What do you think this one's going to be? 6 minus 5 is going to be 1. 1, 4. Let's see, is that a solution? Come over to 1, up to 4. We've already got that one. We got it because we determined it was a solution over here, but I never did that on the right. Do you see how there are patterns both in our tables and in our graph that will help us figure out the solutions to the equations? Okay, let's move on to the next one. Okay, consider the linear equation 2/5 x plus y equals 11. Will you choose to fix values for x or for y? Explain. So which one should it be? The x or the y? Which one has a coefficient? Because again, thinking back to that last problem, if we can get that multiplication out of the way, then we've got a variable that's already isolated and by itself. So I'm going to say x, because I can do the multiplication and solve for y in one step. Looking at 2/5 of x plus y equals 11, are there specific numbers that's going to make my computations easier? Let's think about this. 2/5 is a fraction. If I choose values for x that are multiples of 5, I can take care of my fraction and not deal with specific fractions in my calculator. Think about this. If I've got 2/5 and I'm multiplying it by 5, or 5 over 1, I can reduce before I multiply, and that's going to be 2x plus y equals, I'm sorry, let's undo that part. So 2/5 times, if my x is 5, or 5 over 1, I can take care of that, and it's just going to be 2 plus y equals 11, and then I can subtract that 2 from both sides. So I'm going to say, if I choose, if it's a fraction, I want to choose values for x that are multiples of the denominator. That way I can take care of my fraction before I start multiplying. So I'm always going to start, it says find 5 solutions and plot the solutions as points on the coordinate plane. So I'm going to always start with 0. So 2/5 times 0 plus y equals 11. So 0 plus y equals, I don't know why that second one isn't calculating in there. So 0, 11, I'm going to say is a good solution here. So next I'm going to pick 5 because that's a multiple of the fraction. So 5 for x. So 2/5 times 5 plus y equals 11. Again, I showed you up top, 2/5 times y is going to be 2. Subtract 2 from both sides. 11 minus 2 is going to be 9. Now I can keep this pattern going with positive numbers and just say 10 here, or I could do a -5 if I wanted to. Now if I stay with going up, I can figure out a pattern for my x's and my y's and save myself from doing math later on. So I'm just going to keep going with this particular pattern. These are not the only numbers that'll work. These are just the easy numbers that are going to work. So 2/5 of 10, 2 times 10, well, actually 10 can be reduced to 10/5 can be reduced to 2. So 2 times 2 is going to be 4. I'll show you what I mean in just a second. Subtract 4 from both sides. And this is going to be 7. When I did 2/5 times 10, it would be 10 over 1. I could do the reducing here and just have 2 times 2. That's what I did. Or I could do it like this. 2/5 times 10. 2 times 10 is 20 divided by 5 equals 4. So either way, I'm going to get equals 4. Okay, just a matter of your comfort level with dealing with fractions. All right, right now I'm going to show you that there's a pattern happening here. I'm going up by 5, up by 5, up by 5, and each time I'm doing that, this is going down by 2, down by 2. So without doing any computation in the equation, if I have 15 here, I'm going to say this one's going to be minus 2 again. This is going to be 5. Let's check it and see if it works. 2/5 of 15 plus 5, does that equal 11? 2/5 of 15 is going to be 6, and it works. Now 2/5 of 15, again, you can reduce, or you can say 2 times 15 is 30 divided by 5 is 6. Either way, or do it in your calculator completely. If you're like, yeah, I'm not doing fractions, Mrs. Huntley, that's not going to happen, that's fine. Do it in your calculator. I want you to do the last one on your own. We are asked to then graph these. And if you look at the graph on page 105, there is no x or y axis drawn in, so you have to draw in your own. Now, I'm going to recommend that you do it in a different color. So if you just take your pencil and you draw in your x and your y, it's going to be really hard to see it because the graph is quite dark behind it. So I'm going to suggest a different color. I happen to use a red, and I made my lines really fat, so let me make those a little bit skinnier because we don't need them to take up the whole thing. And the first one that I solved here was 0, 11. So that means my first point is 0, 11. That means I don't go right or left at all, and I go up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's my first dot. My next one I said was 5, 9. So I come right 5, 1, 2, 3, 4, 5, and up 9. And the next one was 10, 7, Okay. Now, before I plot anymore, I'm going to show you something cool here. If I'm trying to get from one point to the next, and again, I've got to drive my car in the main streets, I'm going down 2 and right 1, 2, 3, 4, 5. Down 2, right 5. Down 2, 1, 2, 3, 4, 5. I'm going to say that's my next point. Let's check and see if it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then up 1, 2, 3, 4, 5. Was that one of our solutions, 15 and 5? Yes, it was. So it worked. So I can graph things by using the patterns and by using my coordinates. And each point that I'm saying is on my graph of this line. The x and the y values should be a solution. Let's look at the next problem. I know it's 20 minutes. You're going to hang with me just to get through this next part of the problem. At the store, you see that you can buy a bag of candy for $2 and a drink for $1. Assume you have a total of $35 to spend. You are feeling generous and you want to buy some snacks for you and your friends. Write an equation in standard form to represent the total number of bags of candy, X, and the number of drinks, Y, that you can buy with $35. So we know it's going to equal $35. Bag of candy is $2, and we said candy was our X. So 2 times X, 1 times plus 1 times Y, or just Y, is going to equal 35. So again, keeping in mind that the one with the coefficient is easier to fix and just solve for the Y, I want you to go ahead and pause the video, come up with some values for X and some values for Y. Now you can of course start at 0 and 1, or you can jump around a little bit, see if you can find a pattern. It's up to you. So pause the video right now and see if you can come up with some values. Okay, I started the way I always start. I fixed X at 0 and solve for Y. So when X is 0, Y is going to be 35. When X is 1, Y is going to be 33. When X is 2, Y is going to be 31. See if I can figure out the pattern here. So this is going down by 2, and this one's going up by 1. So my next one, I could with confidence say it's going to be 29 when X is 3. Now I'm just going to get crazy here and put X in as, let's go 6. Let's skip a whole bunch. So 2 times 6 plus Y equals 35. 2 times 6 is going to be 12. And this is going to be 23. The difference between 29 and 23 is 6. The difference between 3 and 6 is 3. Look at this. -2, -6 over 1, -6 over 3. Let's cross multiply and see if they're equal. -2 times 3, -6. -6 times 1. Those are equal. So my change, my rate of change is the same even if I don't go by ones or I don't go in the same order. As long as it's going to work in my equation, my rate of change is going to be the same if I compare. So I'm going to end it here. If you can, go ahead and create a graph. Now, we can't have any negative candy or negative, because this is a purchase, so you don't really have to have any negative values on your graph, just positive values. So please try to complete the graph before you come to class tomorrow, and make sure that you're completing the lesson summary. Remember, we were talking about standard form. That's AX plus BY equals C. A solution is an ordered pair, and we can graph those solutions. Our solutions is found by fixing either our X or our Y and solving for the opposite. Finding solutions is easier if you fix the variable that has a coefficient, and if the coefficient is a fraction, choose values that are multiples of the denominator of the fraction to remove it. So I'm sorry we went long. I hope it was enjoyable, and I will see you in class tomorrow.